All right, I decided to put a little video together here on function, domain, and range, the definitions of them, and how to use them in problems, and some in regular function equations and others in graphs. Um, this is going to be probably going to be kind of a long video because I have a bunch of problems to do. Let me scan ahead here quick. Oh, I guess that's not too many. All those problems, I'm going to talk about these things. And I got all these from your extra practice problems from CPM website. So um, that's where they're numbered as they are. So here we go. I'm just going to jump into this one. This one happens to be number 10 on a particular page. Determine if it's a function and then state the domain and the range. Okay. Function is if there's one output for every input. So um, if I input, let's say this x value, like 1, is there one value of y for it? Yes. 2, one value. 3, one value. Anything, anywhere, any x I pick, I go up and down and I find one value for it. So yes, it's a function. Ooh, let's get rid of that color. And then the domain and the range. Okay, in graphs, I don't know, one way to look at this is to put a box around these things, like this corner, like from that to that, pretty much. Whether you actually draw it or just visualize this box. Oops, let's move that up. And then the domain is the smallest value of the box to the biggest value of the box. So it's like the x's, basically. And the range goes this way. Now, if there's arrows here, that goes on forever, that's not technically inside the box, so infinity is going to be part of your answer, or all numbers or something. So if I look up and down, actually let's do the domain first, that makes more sense. Left and right, I'll get this box out of the way because left and right doesn't make sense to put a box on because this goes on forever to the left. We'll keep going, left, 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 right, 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 forever. So the domain is all numbers. So you have a couple of ways to write this. You can just write all numbers or all real numbers, either way. If you want to put it in the format with the X in it, which is good to get used to, it's just a little more tough for some kids to do. You technically, no or equal to here. I need to learn that in Algebra 2y. It just goes to infinite from negative infinity to positive infinity. So instead of all real numbers, you could just write that. This means all numbers. Okay. But if you do this, technically don't put the equal sign. Make sure you have the negative infinity and the positive infinity right there. So that's domain. And then range is up and down. Now that box does make sense in this case because there is, actually not for this one. For the height, it looks like there is at this top, and the bottom does work, but this does go up forever here. So it looks like domain goes from the minimum that you see on the graph is right here. Nice straight line. -1 all the way up to height-wise infinity. Okay, so I guess I'm gonna write it this way. Um, and then if you're gonna write it this way, you have to put the letter y because it's the up and down the height, and it does include the -1. So I'm gonna go less than or greater, less than or equal to. -1 is less than or equal to y, or y is greater than or equal to 1, and then technically just a less than sign there. If you put the or equal to, I wouldn't mark it wrong with the infinity though at this point. Okay, so this is gonna be kind of good. This is gonna be kind of goofy. If you don't like that format, I would probably accept at this point just say all numbers or all real numbers greater. You can even write out the words if it's confusing with the symbols. Greater than or equal to -1. That might be easier to write at this point. Okay, but just I'm gonna keep throwing that at you so you're exposed to it. All right, let's see if we can go through this one a little bit quicker. Is this a function? Well, let's go to x, like any value of x, like this point right here. Is there one output for this one input? No, there's two different outputs. There's one output there and one output there for this input. So right away, it's not a function. Okay, any value you pick here is going to be two answers. Here's one, but there's two. So that's going to be a no. But we can still figure out the domain and the range. Domain, if I go left and right, it goes from this value forever to the right on this graph. So this is from -3. So you could say all numbers greater than or equal to -3. That would be totally fine. If you want to do the infinity thing, -3 is to the left of the positive infinity. Infinity is over here, so your symbols will always face this direction. It includes the -3, not the infinity, and these are x because it's domain. So you could do that. Okay, I'll keep showing you both answers. The range, up and down, goes up for forever, goes down forever, so it's all numbers. Or -infinity to infinity. Range is y, like that, one of these two answers. Oops, back. 12. Is it a function? Well, just pick a few points, check. Vertically speaking, I only see one y for this x that I picked. Go over to this x, like 2. There's one value on the graph. There's nothing below it or above that. One value. Everything's all one value. No matter what I pick for x, one value for y. So, yep. One output for every input. The domain then, left and right, this keeps following this pattern. You have to kind of assume it's going to follow the pattern unless I tell you differently. Since it continues to follow the pattern, it's going to go on forever to the left. Those are supposed to be arrows. And same thing on the right. So all numbers, or all real numbers. And again, -infinity to +infinity. And this is domain, so it's x. So you could do that. The range then, up and down, well, it does max out at this height. And this minimum's right there. Okay, so the max, I'll go start with the minimum. Minimum is -2. It does include the -2. Keep these in the same direction. The max is +2. And these are y's. Okay. You could also say, I guess you want to write out the words, all numbers between, nice handwriting, between the -2 and +2, but you have to put the word inclusive, which sounds goofy, I know, but it just means, what the heck is that? Is that supposed to be a comma? Oh, it's supposed to be an and symbol. And still looks, whatever, you get the idea. Inclusive just means including the endpoints, so including the -2 and the +2. 13, is this a function? Well, for every x, there must be one y. If I go to this x, it's a single y. This x, single y. All these seem to work. But look at these 2 points right here. If I go to -1, there's 2 different y's for the same value of x. So just because of that one instance, that's not a function. The domain, what can I plug in for x's? All these x's that make sense? Well, I'd actually have to list them because it's not like between things. I really don't feel like listing all these right now, but something, I'll just start listing them. Like -4, I'll make them from the smallest to the largest. -4, it's the actual values. Okay, so -4, -3, -2 doesn't have anything, -1 does. I guess this will go pretty quick. 0, 1 has one, 2, 3, and 4. So -4, 3, 1, 0, 1, 2, 3, 4. So all those values are the input. Okay, that is the domain. So there's nothing like in between there that works for domain. So then once I've input those, what's my output? It's the height. So my lowest is -4. And you might want to write here x equals, and here you might want to write y equals. If you don't, that's fine. I get the idea here. So here y equals -4 for a height, -3, -2, -1, 0, 1, 2. So I guess here I could do like this because it's everything. It goes up to 2, 1, 2, something like that. I'm going to put my little set notation because I'm used to seeing those. Okay. Here, I'd like to put -4 to 4 here, but it's not including the -2. That's the only exception here. If it follows a pattern, did I forget -3? I forgot -3. Somebody was about to tell me that, weren't you? So -3 here, -4, -3, -2, all the way up to 2. These go by ones. It's showing a pattern. Okay. That's really all I can do for that one. It's a goofy problem. 14, function. Okay, I'll mention the vertical line test again here, which I haven't mentioned in the video, but I've mentioned in class. The vertical line test is if you draw vertical lines and it only touches lines in one spot, it's a function. I just really need you to understand why that works. Can I do that? Yeah, I can. Because for every x that's input, there's one here. One value. One value. Meaning if I draw a vertical line, I can check quickly to see if there's a second value on that line. Nope, only one, only one, only one, only one. So with graphs, it might be handy to use the vertical line test. And the domain, what can I input for x? Everything, because it goes left forever, right forever, okay, like that. And if I want to write the infinity, again, these are x's, you could write that. For the range, up and down, okay, it's above that value, goes on forever this way. So I would write, I guess, with this, in this notation, it goes from -2 up to infinity, or I could say all numbers greater than or equal to -2. That's what I would write there. And 15, is it a function? Vertical line test right away, it's a no. Or just double check, hey, I'm going here, there's an output. For the same x value, I have a second y value, a different output. That's why it's a no. And then my domain, what can I input? It goes all the way, like this one is actually a good one to put a box around because it doesn't go on forever. Let's try to draw a square. Is this gonna work? Let's try it. Pretty close. All right. Inside the square then, because it goes, it's totally included inside the square. So it goes from this point to this point. So from -2 to +4. That's how I'd write that if I'm using that notation. Otherwise, you could just say again, between -2 and 4 inclusive. The range, up and down, same thing, -2 to +4. So same answer. The thing here is make sure you put a y for the range. And again, you could say in words, between -2 and 4, comma, inclusive. All right, let's get off these graphs and get into this fun stuff. State the domain and range for these functions. Okay, what can I input for x that makes it make sense? Like, can you put in negative numbers? Can you put in 0? Can you put in decimals? Can you put in positive numbers? That's kind of what you're looking at, and still be able to do the problem. Like if it's a fraction, you're not dividing by 0 kind of a thing. All right, I can put positive numbers here. Obviously, 5 minus something. Just solve it, then square it. No big deal. Could I put in negative numbers? Sure. So domain is all numbers. I can put in anything I want for x and it makes sense. I'll get an error on my calculator. My calculator doesn't explode or anything. The range is a little different. Once I put in any number here, -10, let's say, 0. Let's say I put in, let's not write it that way. Like I put in -10, I get an answer. I square it, big number, no problem. 0, plug it in. 5 minus 0 is 5. 5 squared is 25, positive number. 10, 5 minus 10 is negative, but when I square it, positive. So my point is, no matter what happens, I'm always going to get this thing squared, which means positive, unless it's a 0. Like if I input the actual 5, 5 minus 5 is 0, 0 squared is 0. So my range then starts at 0 and stays positive. So all numbers, let's say greater than or equal to 0. Okay. You could say all positive numbers, but be careful, that does not include the 0. So if you said all positive numbers and 0, that would work. And if you want to do it in this format, y is greater than 0, that'll work. If you want to include the infinity, here you go. Not the or equal to, though. I guess I told you not to do that. All right, how about number 5 here? Let's go, what can I plug in for x? Again, anything. So all numbers. Anything makes sense. I can plug in 0, I can plug in numbers. The thing is when I plug them in, I square them, I get something positive right here. Okay, so like if I plug in 0, I get 0. If I plug in a positive number, I get bigger than 0. If I plug in a negative number, I get bigger than 0. So without the -5 part of it, my range would be the same as this problem right here. Okay, everything positive and 0. The thing is I need to subtract from everything positive and 0. So my smallest value I'm going to get is actually -5. Here I'm going to say all numbers, I should do a different color. All numbers greater than or equal to -5, which is kind of tricky. So this is how it's going to make sense. If I plug in uh, 10, 20, 30 big numbers, or negative 10, negative 20, negative 30 big numbers, no big deal. I square them, I subtract 5 big numbers. Okay. It gets tricky when I get around 0. Okay. If I plug in whatever the square root of 5 is, okay, and I square it, I get to 5. So this was replaced with the 5. 5 minus 5 is 0. So we're still at 0. But what happens if I get to, if I try anything else besides that, it's not going to make any sense. It's not going to, here, let me get rid of this. I can't get less than, I don't know how to explain this. If I guess the best way to explain is like just pick little numbers, like 1, like maybe almost an XY table. 1 squared is 1. 1 minus 5 is negative 4. 2. 2 squared is 4. 4 minus 5 is negative 1. Okay. These answers are all bigger than negative 5. Okay. If I actually figure out what the square root of 5 is, put my calculator here. Oops. That's 2.23. So if I plug in 2.23, well, no, it's not, it goes on forever, but ish, it's the actual square root of 5. If I plug that in, that's where I get squared minus 5 is 0. Okay, that's where I get the 0. If I go the opposite direction, or if I try to force this to be like a negative 6, like I'm trying to make this less than negative 5, I can't do it. I try to go to 3. 3 squared is 9. 9 minus 5 is a big positive number. So that's way above negative 5. So no matter what, no matter how I'm trying to squeeze, even if I plug in negative numbers while I'm squaring them, they become positive. So this is as close as I can get. So my output here, when I get right 1, if I plug in 0, maybe that's closer. 0 squared is 0. 0 minus 5 is negative 5. As soon as I go into negative 1 or positive 1, I'm moving my way back up. Okay? And it's because this graph actually looks like this. If you graph this, it's a parabola. So any x I put in, the lowest y I'll get is right here. Okay, you don't see that, but that's how that's working. All right, I dragged that sucker out. Let's talk a little quicker on this one, sorry. 6. What can I plug in for x to make it make sense? Well, it seems like I can plug in anything except be careful with the fraction. You don't want the bottom to be 0. So I don't want x squared minus 9 to be 0. So to actually, for the purposes of the problem, we actually solve it and make it equal to 0, like I just wrote, and solve it. X squared equals 9, so add 9 to both sides. So x could be positive or negative 3, like when I take the square root here, plus or minus, or do it in your head, like what squared will give me 9 to make it 0? 3 squared is 9, negative 3 squared is 9. And when I do 9 minus 9, I get 0. So there are my two no-nos. If I plug in a 3, 3 squared is 9, 9 minus 9 is 0, I'm dividing by 0. So domain is all numbers not equal to plus or minus 3. I'm just going to write it like that. All numbers not equal to 3 or negative 3, if you want to write that out. Make sure you know that symbol is not equal to. It's an equal sign with a slash. And once I put in all those values, okay, what do I get as an output? Do I get everything as an output? Okay. And the answer is yes, you put as long as you don't put in a 3 or a negative 3, everything makes sense. You'll get positive, negative numbers, fractions, decimals, everything. So this is just plain all numbers. As long as you don't put in 3 and negative 3, you're okay. Okay, because you'll get negatives and stuff when you put in negative numbers for x up on top there. All right, and 8. What can I input here? Well, I don't want negatives to be under the square root. Okay, so I don't want 5 minus x to be less than 0. Okay, or it can be equal to 0. I just don't want it to be less than 0. So if I move this stuff around, if I put the x on the other side, the 0 on this side, I get x over there. If I go plus x, So I have x is greater than 5 or 5 is less than x if I read it the correct way. Okay, x is bigger than 5. Actually, it could be or equal to in this case, isn't it? We don't mind if it's equal to it. Okay, so I can input anything that's 5 or bigger. Actually, I don't want to input something that's 5 or bigger. I got to backtrack here. If x is bigger than 5, like I'll put a 10 here, and I have that going on. Okay, so I don't want this to happen. Okay, so domain is all numbers, I guess, not greater than 5 or equal to. One way to write it. If it's not greater than 5, it is less than 5. Okay, so let me kind of half screwing up here with this little or equal to here because I'm working backwards. All right, so let me try to unconfuse you. I don't want this to be bigger than 5. It can be equal to 5. My apologies here. So you could say the domain is everything less than or equal to 5. That works. So that's probably less confusing than trying the double negative because I just confused myself there too, didn't I? So all numbers not greater than 5, or you could say all numbers that are less than or equal to 5. And then the range, once I put those in there, if I take the square roots of stuff, it's always going to be positive numbers. So all numbers, I should do a different color. All numbers greater than or equal to 0. That's what you'll get. And then last problem, what can I plug in for x? Anything. But then I'm going to square it. No matter what I put in, positive and negative, squaring, I'm going to get a positive number. That negative out front as an output turns it back into negatives. So no matter what, my range is going to be negative numbers or 0. So all numbers less than or equal to 0 would be the range. Whew, long video and a couple screw ups, but I think you get the general gist. Not bad for just winging it, I guess. All right, good luck.